Good day, everyone. I'm Sir RJ Leeson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about basic concepts in mathematics, language of sets. Let us define first what is a set. A set is a well-defined collection of distinct objects. So these are the following we need to remember class if we say or if we write a set or a well-defined set. It is usually represented by a capital letters, the objects of a set separated by commas. The object that belong in a set are the elements or the member of the set. It can be represented by listing its element between braces. A set is a well-defined if the element of the set are specifically listed. So these are examples of the set. So we have here set A. The set A, the elements in the set A is A, E, I, O, and U. So these are the vowel letters, right? So when you write a set, the set usually represented by capital letter. In here, we represent it as capital A. And then the objects or the elements of the set, we have here the elements A, E, O, U, and then separated by commas. So we have here, and also it includes here braces in your given set. Another example is the set of colors. So we have colors or the elements red, blue, yellow, green. Another example, we have set C. We have the elements from numbers 1 to 5. So we have here the given elements 1, 2, 3, 4, and 5. In writing a notation of a given set, if S is a set, the notation X, when you read this one, X means that X is an element of S. And if you read this one, is X is not an element of S. You need to remember that symbol, this is the symbol for the element. And if you write the symbol for your notation, again, it must be a capital letter. When you write also a variation of notation is used to describe a very large set. For example, we have here set 1, 2, 3, and then you put dot, dot, dot until the last term of your given element. For example, it refers here the set of all positive integers from 1 to 200. Another example we have here, the set of all positive integers. So when we write this one as a set, so we have here 1, 2, 3, and then you put the ellipsis. The dot, dot, dot here, the 3 dots, this means that it is called an ellipsis, and it's read and so forth. So we have here 1, 2, 3, and so forth. Using the set rooster notation, a set may be specified using a set rooster notation by writing all the elements between the braces. We have here an example. So let A, we have set A here. The elements are 1, 2, and 3. Set B, we have 2, 1, and 3. And set C is 1, 1, 2, 2, 3, 3, 3. The question is, what are the elements of A, B, and C? So we can see here the elements, they have the same elements. We have 1, 2, and 3. And how A and B and C related to each other? So we have here, again, they have the same elements, 3 elements, which is 1, 2, and 3. And then therefore, A, B, and C are simply represented in different ways. You look at element C or the set C here, set C rather. So we have here in order value 1, 2, and 3. And in set B, in disarranged, no? So we have 2, 1, and 3. And then in set C, the terms or the elements are repeating. So 1, 1, 2, 2, 3, 3, 3. But that means they have the same, also that means just they have the same 3 elements, which are 1, 2, and 3. Now the question is, the element 1, is it equal to 1? The element 1 is not equal to 1 because the element 1 is a set of with one element, namely 1, and whereas 1 is just a symbol or representation that represents the number 1. You need to remember that when you write a set, that means you need to put that in the braces that is not equal to just one number. Or for example, the element of 0 is not equal to 0. Now we have to remember also the Cartesian set of numbers. Some important sets are the following. So when you say the set of natural numbers, you just write here capital N, and the sets are 1, 2, 3, and so forth. And then the set of whole numbers is W. We have equals to 0, 1, 2, and 3, and so on, so forth. And then the set of integers. So we have here negative integers and positive integers. So represents by Z, capital Z. The Q here, that the set of rational numbers. When you say rational numbers, these are the terminating and repeating decimals. And we have here Q complement with the set of irrational numbers, or the non-terminating or non-repeating decimals. Rational numbers, the whole numbers and integers is under rational numbers, and rational numbers and irrational numbers are under the set of real numbers. And we have also C for the complex, the set of complex numbers. So we have here a simple illustration of real numbers. When you say real numbers, it indicates rational numbers and irrational numbers. So rational numbers, again, what is rational numbers? Those numbers are repeating and terminating decimals. So under that, we have here natural numbers, whole numbers, and integers. We have here an example, 9. For rational numbers, 9.454545. And then for 2/3, we have 0.66666, right? So that means repeating decimals. Now, irrational numbers, we have here a non-repeating decimals and non-terminating decimals. So for example, the value of here, we have 1.243487. So non-repeating decimals. And for pi, 3.1416. And there are other we have here also square root of 10, square root of 2, and square root of 3. So when you simplify that one in your scientific calculator, the result is the decimals is non-repeating decimals. So those are irrational numbers. So we have here let S denote and let P of X to be a property that element of S may or may not satisfy. So we define a new set to be the set of all elements of X in S such that P of X is true. So when we write here the set builder notation, we use this one. So the X represents the set of all element of S, and then the line here represents such that, and then P of X, and then you put braces also. So this is the set builder notation for the set of all elements of X in S such that P of X is true. So we have here some examples. Given that R is a set of all real numbers, and Z is the set of all integers, and Z positive is the set of all positive integers, describe the following sets. So we have here the set of all elements of real numbers such that -3 is less than X less than 4. So what are the elements here in the given set rooster notation? So that means what are the values strictly between -3 and 4. So that is, we have -2, -1, 0, 1, 2, and 3. So we need to remember, if we will use less than, and greater than symbols or inequalities, that means the terms here are included. So when you put also less than or equal or greater than and equal, the terms are included. So for example here, negative 3 less than x less than 4. So that means negative 3 and 4 is not included in your given set. So next we have the set of all elements of integers such that negative 3 less than x less than 4. So when you say integers, that means positive and negative integers. So what are the values between negative 3 less than x with negative 3 and 4? So it's the same. So the set of all integers strictly between negative 3 or to the set is negative 2, negative 1, 0, 1, 2, and 3. Take note for this one, letter A example, the set of all real numbers. Sorry, it's not integers, it's real numbers, since R represents the real numbers. And now, letter B example, the set of all integers. But then real numbers, again, integers is under real numbers. So that means they have the same answer. And for another example, we have the set of all elements such as of positive integers such that negative 3 less than x less than 4. So what are the positive integers between negative 3 and 4? So that means the elements are the elements are 1, 2, and 3. So you need to identify the given the given set or the identified set here, so that you can identify also the given elements of the given set. So let's have a definition regarding sets. So let's define what is a finite set and infinite set. So when you say a finite or a set is finite if the number of elements is countable. So that means makount lang. So let's have an example. This set A, given set A is the odd numbers less than 10. So what are the odd numbers less than 10? We have 1, 3, 5, 7, and 9. So how many elements are there? 1, 2, 3, 4, 5. It can be count, right? So that means that is an example of finite set. Another example, set B is days in a week. So what are the days in a week? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So we have 7 elements. That is countable also. That is considered to be finite sets. Next, we have infinite sets. What do you mean by infinite sets? A set is infinite if the number of elements cannot be counted. So we have here examples. Set A, the odd numbers greater than 10. So what are the odd numbers greater than 10? 11, 13, 15, 17, 19, and so on. Because we don't know what is the last odd number, right? So that means that is an infinite set. Another example, we have set B, we have positive integers. We have 1, 2, 3, 4, 5, and so forth. We don't know what is the end positive integer, right? So that means that is an infinite set. Another example is set C, we have sand grains on earth. So sand grains on earth is not countable or it cannot be counted. So that is an example of infinite sets. So let us differentiate what is equal and equivalent sets. Equal sets are sets with the same element and cardinality. So what do you mean by cardinality? So that means the number of elements, the total number of elements. So that means to a set to be considered a equal set, we need to look at the elements. They must have the same element and the number of cardinality or the number of elements. So we have here an example. Set A, we have elements L, O, V, E. Set B, we have E, V, O, L. So they have, if you look at the given sets, they have the same elements L, O, V, E. And they have the same cardinality also. Set A, we have 1, 2, 3, 4 elements. Set B, we have 1, 2, 3, 4 elements. So that means that is an example of equal sets. Next, we have example set A, we have 1, 2, 3, 4. Set B, we have 3, 2, 4, 1. So they have the same elements 1, 2, 3, and 4. And they have also 4 cardinalities each set. Set A we have 4, set B we have 4. So that means that is an example of equal sets. Now, what is equivalent sets? So equivalent sets are the set with the same number of elements or cardinality. So we need to remember that equivalent sets are sets that regardless of their element, as long as they have the same number of elements to both sets, that means that is considered to be equal sets. So we have example here. Set A we have MATH for the element, and set B we have PLUM. So they have different elements, right? They're not they're different. So that mean, but then they have the same number of elements, which is 4, or the same cardinality. So that is an example of equivalent set. Another example, we have set A 21, 22, 23, 24, and set B we have 33, 32, 34, 31. So they have different elements from both sets, but then they have the same cardinality. So that means that is an example of equivalent sets. So what are joint sets? Joint sets are sets with common elements. That means they have intersections. So let's have an example for that. So set A we have J elements J, O, I, N, T, and set B we have D, I, S, J, O, I, N, T. So if you look at the set A and set B, they have common elements, which are J, O, I, N, T. And then in set A, another example, 1, 2, 3, 4, 5. Set B we have 1, 2, 3. If you look at the examples, they have the same, or they have common elements, which is 1, 2, and 3. So what are disjoint sets? So disjoint sets are sets with no common elements. So let's have an example. Set A we have A, R, and E. Set B we have H, I, S. If you look at the examples, or the examples of the given sets, they do not have the same or the common elements. Set A also is another example. Set A we have 11, 12, 13, 14. Set B we have 15, 16, 17, 18. As you observe, they have no common elements. So that is an example of disjoint sets. So how will you write, or how will we write a universal set? Universal set is the set of all elements. So we will use the letter U to denote the universal set. Again, letter U for the universal set. So we have here an example. If set A, we have an element A, B, C, D, and set B, we have D, E, F. Then the universal set is, so you will use U as your universal set. You just need to combine all elements from set A and set B. So we have A, B, C, D, E, and F. And then the empty set or null set is the set that contains no elements. The symbol here, like 0 and then slash, or an empty braces, is represented by empty set. So we have here an example of empty sets. Set A, we have the square with 5 sides. Are there square with 5 sides? So no, because squares has only 4 sides, right? So that means that is an empty set or null set. Another example, we have set B, we have day starts with letter R. So we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So there is no days that will start with letter R. That is considered to be empty set or null set. Thank you so much for watching. I hope that you've learned out of this lesson. Please don't forget to like and subscribe and share it with your friends. And watch out for part 2 of this video lesson so that you can learn more about the basic concepts of mathematics, which is the language of sets. Thank you so much again. Goodbye.